Hello and welcome. This is going to be our homework help video for the homework finding sine, cosine, and tan of angles. For these first 8 problems, the only way that you could really mess it up is if you are not in the right mode in your calculator. So let's just go over how to switch the modes really quick. If I'm dealing with a problem where the angle is given in the unit of degrees, then I should make sure that my mode is degrees. I do that by pressing mode right there next to your second button. Scrolling down to wherever it says radian and degrees and making sure degree is highlighted. Now I can do all of these problems that are in degrees. I don't have to plug in the unit. It just knows that since I'm in degree mode, when I say tangent of 204, it plugs in 204 degrees and then gives me the correct ratio there. Let's see, it wants to the nearest 10,000th. That's 4 places after the decimal. So I would round this to here. So 0.4452. 0.4452. Some of these other ones are in radians. So if I gotta switch it back to radians, I'll press mode, then click radian. Back to the main screen of the calculator. Sine of 13 pi over 20. Another way we might mess this up is not to put the whole 13 pi divided by 20 inside of a set of parentheses like this. So sine 13 pi over 20. This will round to 0.8910. 8910. All right, moving right along, we come to these problems here asking for the exact value of each trig function. I think this would be a good time to double check that the recording is working. Looks like it is. The exact value, emphasis on exact here. If the answer is irrational, I want my answer to include the square root, so it's not just a decimal approximation. All right, we'll start with number 9 here. This terminal side has been rotated 11 pi over 6. All that matters is where it ends up, and then we want to figure out this interior angle here. Well, if it's gone 11 pi over 6, and a full revolution is 2 pi, I could figure out the interior angle here by just figuring out the difference between 2 pi and 11 pi over 6. That's going to be the same as 12 pi over 6 minus 11 pi over 6, which equals just pi over 6, which equals 30 degrees. So that angle in there is 30 degrees. Now I come out here, let me extend that terminal side so I have more space to work with. I pick an arbitrary point on that terminal side, and I drop a straight line to my x-axis, thus constructing a right triangle. Now, if that's a 30-degree angle, this is a right angle. The remaining angle must be 60. So now I've got a 30, 60, 90. And we've learned the side lengths of a 30, 60, 90 to be, there's a couple different ways to write this. My favorite is 1, 2, and the square root of 3. We could also do 1/2, 1, and the square root of 3 over 2, but I think this is a little easier to remember. It just goes 1, 2, 3, with the 1 and the square root of 3 being the legs of the triangle. Now I've got to figure out if any of these sides are negative. To do that, I walk from the origin to that point on my terminal side, and if I ever go left or down, that's negative. I'm going to walk along the legs of this triangle. So I'm going to the right, so that's a positive, but then I go down, so this is a -1. Next thing is I've got to label the sides of this triangle with their relationship to this interior angle here of 30. This side length over here is the side length that is opposite of that 30. This side length over here is the side length that is adjacent to that 30. And this side length over here is the longest one. It's always the hypotenuse. Now, after all this work to create and label this triangle, I'm finally ready to go back to the trig function that I want. Sine is always opposite over hypotenuse. So to answer this question, the sine of 11 pi over 6 is equal to -1 divided by 2, or -1/2. We'll just box that. That's our final answer. All right, let's keep trying this. We're going to get better as we go. But if I'm the interior angle for number 10 here, if I've gone 3 pi over 4, and a full half revolution would be pi radians, I could do pi minus 3 pi over 4 to get this interior angle, which is going to be equal to pi over 4, which is going to equal to 45 degrees. So I can put a little 45-degree angle in here, pick a point on the terminal side, drop it down to my x-axis, thus creating a 45, 45, 90 triangle. The side lengths of a 45, 45, 90 could be 1, 1 and the square root of 2. Now it's time to check and see if any of those are negative. Walking from this point to this point, I go left, so that needs to be a -1, and then I go up, so that's fine, just stay positive. Let's label things up based off that angle closest to the origin. This would be the opposite, this would be the adjacent, this would be the hypotenuse. Tangent is opposite over adjacent. All right, that's what the TOA at the end of SOHCAHTOA stands for. Opposite over adjacent. The opposite here is 1. The adjacent is -1. So the tangent of 3 pi over 4 should be equal to 1 divided by -1, which is just -1. If we want to double check that, we could always do it in our calculator. Tangent 3 pi over 4, we are looking for -1, and we get it. All right, but you will need to be able to explain this process. It's, although we can solve problems by just using our calculator, we can't always get exact values when they have square roots, and we can't really explain using triangles why the trig function of this angle is -1 unless we draw a diagram like this. All right, let's just keep going. I'll go a little bit quicker. This is a 30, 60, 90. You can kind of tell just by looking at it if you didn't want to do the subtraction here, because it's a skinnier angle right there. These side legs would be 1, 2, and the square root of 3. That square root of 3 would be negative. This side over here would be opposite. This is the hypotenuse. This is the adjacent. Cosine is adjacent over hypotenuse. So the cosine of 5 pi over 6 is equal to adjacent negative square root of 3 divided by hypotenuse, which is 2. There's a 45-degree angle 1, so it's 1, 1, square root of 2. Opposite over hypotenuse. This one's going to be 1 over the square root of 2. Simplify it by multiplying it by the square root of 2 over the square root of 2. So we get the square root of 2 over 2. So these problems can be that fast once we get good at drawing our triangles, recognizing which special triangle we have, pulling out the correct side lengths, but never skipping the step where we remember to make side lengths negative if they ever go left or down. All right. These problems here, we don't have the diagram. We're going to have to add the diagram ourselves. I'll just do 15 and 16 since that'll be easy to write on. I start 15, I need to draw a negative 240-degree angle. Well, if I rotate negative 180, that lands me there. Negative 180 is 60 degrees away from negative 240. So the rest of the way to negative 240 brings me 60 degrees into this quadrant here. So this is a 60-degree angle right there, 60 degrees. Draw the rest of our right triangle. More of an arrow. If that's 60, then this up here is 30. The side opposite the 30 is the shortest side, 1. Hypotenuse is 2. Other leg is the square root of 3. I remember to make this 1 negative. This is the opposite. This is the adjacent. Here's our hypotenuse. Sine, opposite over hypotenuse. So square root of 3 over 2. All right, we can double check with our calculator. And that brings us to 16. Oh, I'm glad I'm doing 16. 16 is an interesting one. We can still do it with triangles if you draw your triangle in kind of a special way. So a rotation of pi over 2 would normally land my terminal side right along the y-axis here. That's pi over 2 is equal to 90 degrees. But what I'm going to do is I'm going to draw it just slightly off of my y-axis. A little bit of an angle there so that I can still make a triangle. This is just an infinitely thin triangle. All right, we put a little right angle there. We know that it's infinitely thin because we're going to label this side length down here 0, is of length 0. And now the opposite and the hypotenuse of this triangle have to be the same length because they are the same line essentially. So we could pick any length for them, but we always are just going to pick 1 and 1. This is still my opposite side, this is still my hypotenuse, and this is still the adjacent. It's just at exactly 90 degrees, the opposite and the hypotenuse converge to be a single line. All right, tangent is the same as opposite over adjacent is the ratio, opposite over adjacent. Opposite is 1, adjacent is 0 here. So that would be 1 divided by 0. Divide anything by 0, this is undefined. All right, tangent of pi over 2 is undefined. If we try to plug it into our calculator, we're going to get an error message. All right. We've got some angles that are past 360 degrees. Let's figure out how to find the interior angle on number 17 here. So I can draw my triangle at any time. I'll just start by drawing it real quick. Right triangle there. All right. So it's telling me that this whole rotation is 1020. So I'm just going to start counting up to maybe this point here and figure out how much of that's used up. Or I could, as I go, I could subtract from the 1020, but I'm just going to count by 360s. So a full revolution to there is 360. Another full revolution to here is 720. If I keep going, if I add another 180, then I'm at 900 to right here. Another 90, this is 990, leaving 30 more degrees here, but that's not the angle I want. What I want is that interior angle of 60. Once I know that, I can label up my sides. That's going to be a 30 in there. This is 1, 2 and the square root of 3. Make that square root of 3 negative. This is my opposite. This is my adjacent. This is my hypotenuse. Sine is opposite over hypotenuse, so the square root of 3 over 2. That was a negative square root of 3. I just kind of got lost there. All right. Use the given point on the terminal side of angle theta to find the value of the trig function indicated. What we're going to do is we're going to use that point as the point on our terminal side that we construct our right triangle around. On the previous problems, we picked an arbitrary point. Now it's not arbitrary, it's given to us. But that gives us 2 lengths of this triangle because the x value is how far over that point was. So the x value is this length down here, square root of 15, or 17. The y value is then this length over here. Cosine, we do need the hypotenuse for cosine, so to solve for this, we use the Pythagorean theorem. A squared plus b squared equals c squared. So square root of 15 squared plus 7 squared equals c squared. 15 plus 49 equals c squared. That is a 64 equals c squared. Square root. 8 equals c. So this side length in here is an 8. Let's label everything opposite, adjacent, and hypotenuse based off of the interior angle here. This side's the opposite, this side's the adjacent, and this side's the hypotenuse. Adjacent over hypotenuse would then be this 15 divided by that 8, square root of 15 over 8. All right, we'll practice with just one more. Let's see, we do have a tangent one. The tangent one's actually going to be pretty easy because we don't have to find the hypotenuse since the tangent is just opposite over adjacent. I guess this one here looks fine. Drop a line down from your point to construct a right triangle. The x value gives you this length, 2 root 3. The y value gives you this length. Pythagorean theorem, 2 root 3 squared plus 2 squared equals c squared will give us the remaining length. 2 root 3 squared is going to be the same as 4 times 3 plus 4 equals c squared. 12 plus 4 equals c squared. 16 equals c squared. Square root 4 equals c. So this length here is 4. Label things as opposite, adjacent, and hypotenuse. And then for sine, take opposite over hypotenuse. 2 over 4 equals 1/2. And we can't really check this in our calculator too easily because we don't have a theta. Theta was just how much rotation was needed to end up on that terminal side. So we still, even after solving for sine of theta, we still don't even know what theta is. But we're still able to take its trig function because we've got a point on that line. All right, hopefully this has been helpful, and I will see you